Hi everyone, in this video I'll be talking about the enhanced for loop that Java provides, and it can be used over lists and also over arrays. Basically what the enhanced for loop says is for each item, we can call it current, we can call it temp, we can call it whatever we want. For every item in the collection, and then you can use current for something. So you can add the current to the total, you can add current to a counter, you can check if current is negative, positive, even, odd, prime, uppercase, lowercase, whatever the situation requires, and do something with it. A sample syntax is provided here. It says for type current belonging to an array or a list. In future you'll see that the enhanced for loop can also be used for other data structures, and you can use current to do whatever you want. Here's an example with an array. If we create an array of integers, I can add all of them up by using the enhanced for loop as for integer item belonging to collection data, which is the array, and total becomes total plus item. What the enhanced for loop does is it keeps the current item in this variable item, and each time the loop iterates, item changes. So in the first iteration item is 10, in the second iteration item is 70, in the third iteration item is 20, and the fourth iteration item is 90. Similarly with a list, if I create an array list with items 10, 70, 20, and 90, I can use the exact same loop to go through every item of that list. So you can see that there are two benefits of the enhanced for loop. One is the simplicity, and the second is the consistency, that it behaves consistently across an array or a list or any other data structure. What I'll do is I'll explain the use of the enhanced for loop using some examples. Here I've got four methods. The first method returns the sum of all the items in an array list. The second method checks if all the items are positive. And if they are not, it returns false. The third method returns true if the array is in ascending order and false if it's not in ascending order. The fourth method returns the index of the first negative item. And if none of the items are negative, it returns -1. So in the first one, you can see that all we have to do is add the current item to this result. So you say for int item or current belonging to the list, and the name of the list is data. Result becomes result plus that item. Similarly, all positives, you can go for int current belonging to the array list data. What we are trying to check is that all of them are positive, which means even if one of them is not positive, which means less than or equal to 0, you can immediately return false. When the loop terminates, it means that it did not return false, which means none of the items were less than equal to 0, which means all of them are more than 0. So return true. Now we come to the third method. And in the third method, you see that there is a bit of an issue. First of all, what we're doing is to check if the array is in ascending order, we check if an item is more than the next item or the item after that. Because if there is any item which is more than the next item, for example 70 followed by 20, the array cannot be, the list cannot be in ascending order. So you immediately return false. What it means is that it's not easily possible to convert this into an enhanced for loop because you're accessing index I and I plus 1. So in this example, we're not going to use the enhanced for loop. In the fourth example, the first negative index, or the index of the first negative item. Again, because we need the index, because it's the index that you need to return, we need the index for something other than simply accessing the item. But if you really want, you can convert it to an enhanced for loop by saying int for each item belonging to data. If the item is negative, then we need to return its index. So you can return data dot index of item. So you could do that. You could also keep a track of the counter separately. Basically, for every time you enter the loop, increase index, and as soon as you find an item which is less than 0, return that index. So it's really up to you. Which solution do you want to choose? Do you want to choose this solution, or you want to use index of, or you want to use the counter-based loop? All solutions are correct. We're going to run this program, and for the array 10, 70, minus 20, and 90, you can see that the total is 150. They are not all positives. It's not in ascending order, and the first negative item is at index 2. Changing that to 10, 70, 80, 90, or better still 10, 70, 70, 90, the total is 240. They are all positive. It is in ascending order, and the first negative item is at minus 1, which means it doesn't exist. If I change the first item to 0, they are not all positives, but they are in ascending order. So I hope you make use of the enhanced for loop when required. It's very useful. It makes the code compact and much easier to implement. Thank you very much.